time for pain. We're doing this stuff, but Matlab coding is gonna be. I mean, I already did most of it, so it's fine. But it's gonna be, Anyway, so we're gonna start with the work line integral, which is basically just showing the process of it. I didn't really did the proof of it or the actual description of it of what it actually is. I will be doing the description. I'm not sure if I'll do the proof of what that really means, I don't, because it's a pain in the ass. What I mean by that is the proof of this, like what it actually represents and what the proof of that really is. So whatever. I think there's also proof for a curl, and then y is a measure of rotation. If I remember correctly, there is. It has to something with the gradient and then the potential function, maybe. No, it wasn't a potential function. It was definitely due to the gradient. And you do some weird shenanigans with the gradient. Do this. I'm not doing that yet. There's also the polar version of it, and then there's the spherical, and then there's the cylinder version of it. I'm not sure if I want to do that, so I did all Cartesian. Yeah, we're starting with radical because this is famous. Everyone knows about it. Um, yeah, and then here's the MATLAB code. Here's the MATLAB code, powered by going back to my notes and looking at shit I did for 20D, Math 20D, and then and then looking at shit in ChatGPT and combining those two and figuring this out. That's all I did to figure that out. MATLAB is so much fun. Not everyone knows it's not. It's the most painful part of 20D because they don't give you enough instructions on how to do it. They literally just dump the whole text and makes you read it. Yeah, no one likes it. Um, I wish they kind of wish the professor would teach you some of it, but at the same time, they do give you the functions to make things easier. So, whatever. It's a give and take. Usually, MATLAB. I love MATLAB and I hate MATLAB. It's a love hate relationship, in my personal opinion. I love MATLAB sometimes, and I also hate MATLAB. Though part I love about MATLAB is that you can make things so clear. Like I adjusted the factor, this auto scale factor to 0. I thought I increased it to 1, but you can keep on increasing it to 0.2, 0.1 to make these arrows look good. And then you have a lot of free accessibility of labels and other legends and all the other stuff, which kind of, and I said origin source of field. It's actually a sink of field. Um, it wouldn't matter for you because this is 20E, but in a real sense, in the fluid dynamics, this would be a sink. I guess it could be a source either way. I don't know. I forget. Uh, but I don't want to change all the code and all that right now because I just realized that mistake. I probably will fix it eventually, but mm, yeah, I'm too lazy probably. Anyway, we're going to talk about path because unlike regular integral, this path when we talk about going to here is not. I repeat, not. The graph doesn't represent area. It does not represent area. These vectors are x and y, and then they're showing you if you go from this point to this point, the integral should be the same no matter what path you took. You could go all like all the way like randomly doing this shenanigans, getting a uh paratermized, excuse me, a weird line in like x4 plus 3x square plus 1 with an n with the ln to get this function. As long as we hit those 2 points, we can find the integral. And I mean point here and point here, because that's the one I defined, a and b. So more, and then we get the first parameterization I did, which gives me flashbacks to funky U sub because I made a mistake there, and all U sub. So what happened was I forgot to do a step that at least the textbook that I seen skipped. And then I remember some my high school teacher telling me that you should probably do that because that will help you out. because it'll make you understand. I will go there right now. Just so you know, I did AB there, so I could skip in the college. So that's why I didn't get told by a professor about this instead of a high school teacher. Anyway, this part over here where you do this is nothing major. Anyway, let's go back over here. Where was it? Blah 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 blah. Line integrals. Clearly, are not done. It's just an update. Pain in the ass. Sometimes the Matlab will be. And then I get this. So the best one is number one. If you have the option, always do number one. Now, if you have to do number two, where we have orientation, where we have the same end point, they're same, you have to get a grain of salt, because if you get from here to here, no, number two. If and only if it's, well, it's not only an if and only if, because it's not technically only and only if for uh may be conservative if and only if. I mean, that works. I said maybe, right? Conservative if and only if because you have to say, if this is wrong, then it can't be true. So it works now. Anyway, so if you have if you have two integrals like going like this and this, going to somewhere here, and it goes to the same endpoints and don't get the same integral, that is not conservative. But if you get the same end value, so after you completed the integral, you have to be the same. If it's not, then we have a problem. So then it's not conservative. But it's not a definite proof, because it can't be a proof, because there could be a case where, let's just say, I don't know, that for some reason that those 2 points for some reason allows it to have the same what's the given area under this weird shenanigans, but when you figure out in the other points is not conservative. So the vector field itself cannot be conservative, or the line itself created that possibility of it being look like conservative, but it's not. These are rare cases, so it usually would work. Number three, on the other hand, is if you do a loop, if you do a loop, like a closed loop, just keep on going around. If it's still zero, then you got a winner usually. And in rare cases, you could jump, you could not notice it, but I mean, there could be a point like that, and then another point that doesn't do that way, but most likely not. So this is true usually. Now we have this. Now this is gravity. And here's a partial derivative of all this. I don't think you want me to derive each and every one of them, because they're the same eventually. And as I said with partial derivatives, you treat everything else as a c, or I don't know, that's just a number. So yeah, so I don't think I want to derive this, or I don't want you guys to really deal with this. It would be a pain in the ass. Uh, yeah, it'd be very much a pain in the ass to all of them, because it's very boring. It's the same thing. As you can see, this one cancels with this one, and so on and so forth. It's kind of obvious that it would have to. No, it's not obvious. What am I talking about? And then once you get it, you get zero. There's a and then this is true. Uh, um, and I'll have to explain. Yeah. Um, I have to explain this. There, I not don't want to right now. Um, I'll explain it later, because I have two more examples I have not finished. Um, that will explain most of that shenanigans, so we're fine. Um, Next we have this one, right? We have the near zero, and then we have the visual. This thing, this funny fun fact. When I was a kid, I always tried to understand G F equal ma with the G equation with the divided by r. I didn't understand it. You know why? Because I was trying to figure out the way to calculate it, so we can actually figure out something like the acceleration of an object going like this, and incrementally, and I could never figure out how to do it. But with a line integral, I can finally do it. Just to do a line integral from here to here, and you can figure out the change over here very fast. This right line integral, the integral which will give you. Wait, what would it give you? The integral will give you velocity, then it'll give you displacement. You can figure it out, and then you just see initial conditions for each and every one of those things. But you know what I mean. Um, what else did I change? Nothing else. Just blah Matlab. So pain, Pain, pain. Okay, so I'm just gonna stop here. This was Matlab. I almost forgot. I should probably show this off. All the cool stuff about this. Here you go. As you can see, the red line is 0, so that makes sense. Quickly, this is why it's horrible. Doesn't work. I mean, it does work, but it's just yeah. I found that online. It didn't really help me. And then what else? Here's a contour map. Did I do anything? Oh, did I show the Jacobian? Oh, I did change things in Jacobian. I forgot. So Jacobian coordinate system, I have changed a little bit of it from last time where I started doing all of the like putting this in over here where we did the coordinate transfer to infinity, and then did I show that off? I think I did. Yeah, I think I showed this off. So yeah, that's fine. But I don't think I showed it off here. So let's really quickly show it off here. That's not right. I think it's this one. Yes, that one shows off that one. I don't know why I made two of them. This one shows off the circular. Oh, did I delete one by accident? I think I deleted one by accident. Yes, the green one got deleted or changed into this. Or no, I got deleted, I guess. No, it's here. Okay, so I'll just save that. What else did I do here? I did graph this to actually see that the sign was correct. It is correct. Um, Here is the different matrices I made. Yay. And it was really fun to see how it would turn out. Well, let's see. Um, let's see. This other one shows this, I guess. This was just showing off that. Did I delete the one where I did the? I must have. Yeah, I think I did. Unfortunate. That was one of my favorites. Thought I saved it. I guess I forgot to save it. Um. Oh, it's probably one of these over here. I'm not going through that to just figure out the. Oh wait. I think I know which one was it. Probably the last two on the bottom. Yes, it was the last two on the bottom that shows that off the coordinate change really. And I'm done now. Bye bye. I'm done.